In problem number 14, which I'm not going to write here, you have to refer back to the exam, but if you look down to the last sentence, it says, how many boats of each type must be produced for the plant to operate at full capacity? So what we're really doing is we're counting the number of boats that we want to produce. So that's what we're going to let our variables be. So why don't we start here? We'll let X be the number of one-person boats that we're going to produce. And then we'll let Y equal ... the number of two-person boats, right? Two-person boats to be produced. And Z, well, that'll be the number of four ... the number of four-person boats to be produced. So when we set up our matrix here, what we're going to do is these are going to be the categories. These are going to be the columns. So we're going to have three columns. So we're going to have an X, Y, and Z column, so we can write that. We'll have a column for X, Y, and Z, and then we'll have some totals out here. And then along the rows, we'll put our characteristics. So what do you know about these categories here? Well, each one has a certain characteristic, and in problem number 14, it looks like we've got cutting, assembly, and packaging. So we have some cutting time, assembly time, and packaging time. So those are the characteristics of each one of these categories. So the way this is read, it looks like right from the second sentence, each one-person boat requires, and then it tells us what those are. Then it goes to the two-person boats, then the four-person boats. So let's just read down the first column. So let's see. We are going to have, as I read down, it looks like I'm going to write 0.5. Let's get that. 0.5, and then 0.6 and 0.2. And that corresponds to the 0.5 hours of cutting, 0.6 hours of assembly, and 0.2 hours of packaging. And then for the two-person boats, reading down that column, we're going to have 1 hour, 0.9 hours, and 0.9 hours, right? 1 hour for cutting, 0.9 hours for assembly, 0.9 hours for packaging. Let me just check that to be sure. Yep, that's what I'm reading. And then for four-person boats, reading down that column, we're going to have, let's see if I can read down that column, we're going to have 1.5 hours for cutting, 1.2 hours for assembly, and 0.5 hours for packaging. Now we want to run at full capacity, so we're going to run at all 380 hours that we have available for cutting. That would be full capacity. And then we have 330 hours for assembly. We'll use all of those, and 252 hours for packaging. So here's our matrix, and if we set it up like this, that's what we're going to put into matrix A. So first of all, we may want to write the system. So this setup right here, we can write as a system if we're asked to do so. So to write the system is going to be this set of equations, right? We'll have three equations, three unknowns. We'll have 0.5x reading across the rows, plus, I'll write a 1y to make it clear, plus 1.5z, and that's going to be equal to the 380, right? I've just gone through the first row. 0.5x plus 1y plus 1.5z equals 380. And then the second row is going to give us 0.6x plus 0.9y plus 1.2z. That's going to be 330. And the third row, 0.2x plus 0.9y plus 0.5z, that's the 252. And now, if we put this into matrix A, right, make that matrix A, and then what you want to do is an RREF on matrix A. And when I did that, I got, okay, RREF, so you know it's 1, 0, 0, 0, 1, 0, if it's going to have a solution, 0, 0, 1, and then I got 20, 220, and 100. So now to operate at full capacity, if we just read off our solution here, right, this tells us this 1x, no y's or z's, 1x is 20, and x is, follow it up, the number of one-person boats to be produced. So the company should do what? It should produce 20 one-person boats. I'll write that down. And then the company should produce, all right, no x, 1y, no z's, 1y, y is 220, but up here, y is the number of two-person boats. So we should produce 220 two-person boats. And finally, 100 four-person boats. And that's the solution to our problem. In problem 15, see if we can set it up like we did 14. In 15, okay, and again, I'm not going to write it down here, so you'll have to look at the actual question on the exam. But I'm going to go down to that last sentence, and it says, how many ounces of each food must be used to meet the diet? And as I read through this kind of quickly, we've got three foods, right at the very top sentence. We've got three basic foods, food A, B, and food C. So I'm going to let my variables, X, Y, and Z, be the number of ounces of each one of those foods. So what I did here is I let X be the number of ounces of food A that we're going to use. Y is going to be the number of ounces of food B that we'll use. And Z, that's going to be the number of ounces of food C that we're going to use. So now, as this always goes, these variables, or the food groups, if you want, A, B, and C, these are our categories. They're going to go across the rows. So when I write my matrix here, I'm going to have, say I do it in A, B, and C. You can do it in X, Y, and Z if you like. And then we're going to have totals. So those are our columns, right? The columns are the categories. A, food group A, food group B, food group C. And each one of these categories meets certain characteristics, or has certain characteristics that go along with them. Each food apparently has some calcium, iron, and vitamin A. So we're going to have some calcium, some iron, and some, say, vitamin A. I already have an A up here, so I'll use VA. All right, so let's read through here and see what we've got. Now, the way the question's worded, it says the diet is to include, all right, 340 units of calcium. All right, so first of all, let's fill this in. So we know, here's calcium. We have to have a total of 340 units. So we have to have 340 units of calcium. And then it says 180 units of iron and 220 units of vitamin A. All right, that's coming right out of that second sentence. And then the third sentence says that each ounce of food A contains, all right, then it tells us the number of ounces of, or units of calcium, iron, and vitamin A. So for food group A, it's 30 units of calcium. So this is going to be 30 units of calcium, 10 units of iron, and 10 units of vitamin A. And the next sentence tells us about food group B. In food group B, we've got 10 units of calcium, 10 units of iron, and 30 units of vitamin A. And food group C is 20 of each. So here's our system. If we want to write the system, it's going to be 30x plus 10y plus 20z. That's equal to 340. And you see where that's coming from. Just reading that first row. 30 x's plus 10 y's plus 20 z's. That's all equal to 340. And then just continuing on with the other two equations, we'll have 10x plus 10y plus 20z. That's equal to the 180. And the 10x plus 30y plus 20z, that's equal to the 220. And there's our system. So if we put this in right here, if we put that into matrix A, that 3 by 4, right? It's a 3 by 4, so put that into a matrix A, and then we'll run an RREF on matrix A, and that is going to give us, okay, our diagonals here, 1, 0, 0, 0, 1, 0, 0, 0, 1, our vertical line. And then reading those constants, I got 8, 2, and 4. So 8, 2, and 4. So this tells us, this tells us right here that x equals 8, y is equal to 2, z equals 4. But of course, we're not going to report our answer like this. This is a word problem. So what we do in word problems, we follow it all the way back and we see what x, y, and z are. So x is the number of ounces of food group A. So what are we going to do? We're going to use 8 ounces of food group A. So what we're going to have here is, I'll write it over here. Okay, to meet the diet requirements, we are going to use, 8 ounces of food A. And then, what is this? This is y, right? No x, 1y, no z. 1y is 2, but y, follow it up. Y is the number of ounces of food B. So we're going to use 8 ounces of food A, 2 ounces of food B, and then 4 ounces of food C. And that is the solution to our problem.